About 2 years ago, I was doing research for a video on the origins of the 3.5-inch floppy disk. This magazine was something I picked up as part of that process. It showed the Jonos Escort, which I determined was the first computer to ship with 3.5-inch floppy drives. But it also briefly mentioned another machine called DOT by Computer Devices. My research on that computer found that it released after the Jonos, so it wasn't important for that video and I omitted any mention of it. But I also omitted it because I wanted one. The only problem was that there were only 500 examples ever sold. But 2 years later, it finally happened. Today, I am so excited to share with you the story of the DOT, the first PC to ever ship with 3.5-inch floppy drives. There is so much to talk about with this machine. It's a striking computer with an incredible amount packed in, but its history is also critical to understanding it. Let's start with a quick overview of the machine, then get into its history, and end with some more in-depth looks inside and what it's like to use. This is the Computer Devices DOT, and right off the bat, yep, that is a widescreen CRT. This was meant to have it work better for word processing software for its integrated thermal printer. It can show a full 132 characters per line, the standard for most printers at the time. Inside it is an IBM PC compatible computer with an 8088 and a minimum of 32K of RAM. On the back it has connectors for the keyboard, monitor out, and 2 serial connections. Then we get to the drives. These are Sony OAD30V floppy drives. These are the first generation of 3.5-inch drives available. To put a disk in, you must first open the shutter manually, depress the disk hub clamp, insert the disk, and release the clamp. These drives are what make this computer so uniquely interesting, but also what destroyed both it and the company behind it.
Computer Devices Inc. was founded in 1969 by William Northfield. He was previously a high-level executive at Analog Devices. He borrowed $100,000 against stock he accrued from his time at Analog Devices and used that to found his company. Don't get too attached to Northfield though, because he sold the company in 1970, bought it back in 1972, but only retaining 20% ownership, and was then fired as the president in 1975.
He was there to oversee the company create and sell some of its first products though. CDI started out making portable hard copy terminals. These were used to communicate with mainframe systems from remote locations, like traveling salesmen, as detailed in this article talking about using one of CDI's mini terms with a DEC mainframe. These machines printed directly onto paper instead of using a CRT, and could dial out with an acoustic coupler. Even though these devices don't have a particularly complex job, CDI continued to innovate their offerings with new features. Their first successful model was the 1030 in 1972, a 300 baud ASCII printing portable unit. By 1973, the 1030 was offered as many different variants for compatibility with different mainframes. 1977 is where it gets really interesting though. CDI unveiled a whole new 1200 model line at the 1977 June National Computer Conference. The printer at the core of their terminals was now available as a module for OEM purchase. The 1201 was a standalone read-only terminal that was effectively just a printer. But let's cut to the good stuff with the 1204. This model introduced 32 kilobytes of RAM, microcassette-based local storage, and a built-in text editor to prepare data in advance to send. This was essentially a bare-bones word processor. But it gets crazier. After they ruggedized the 1204 as the 1205 with an acoustic coupler, they introduced the 1206 Pro in 1978. The Pro stands for programmable. This terminal, nay, computer, ran BASIC and could be user programmed. There's even a demo at the 1979 NCC where they showed disk drives with an operating system. This was the peak of Computer Devices, and they had a very solid product line. I wanted to give you this overview up to this point because CDI was making robust and complex devices in the terminal market already, and as the market was clearly shifting away from central computers to personal ones, CDI needed to look for new market opportunities to continue to flourish. Going into the 1980s, Computer Devices started work on two large projects. The first, which was introduced in June of 1981, was the new Series 2000 line of terminals, with the 2300 being the first shown. These terminals appear to mostly have been about modernizing and cost-reducing their production. There really wasn't much else to achieve in the terminal market. But getting the manufacturing up and running for these terminals didn't go smoothly, and it wasn't until December of 1982, a year and a half later, that these units were actually being produced and shipped. A massive delay for their finances especially. This added to the problems their other product would face. At Fall Comdex in November of 1982, Computer Devices unveiled the DOT. This unit looks almost exactly like what my final production example looks like. They clearly had the design finished at this point, but they were still trying to get the Series 2000 terminals out the door and couldn't make the DOT yet. This compound delayed production of the terminals and DOT strained the company financially to the point of no longer being profitable. They had heavily invested in these projects and were massively in debt. The IBM compatible market was brutal and unforgiving, and as one analyst at Comdex, seeing the over 1,000 vendors on display, stated, there are just too many products out there. The delay of the DOT opened the door for competitors like Compaq to get the lead. So when the computer would finally release, it was already an uphill battle. But what CDI didn't know is that they had lost the war before they even began the fight. I did an entire video about the origins of the 3.5-inch floppy drive that Sony created and worked with industry leaders to rally around as the new standard for floppy disks. A proposal for what would become the standard 3.5-inch disk wasn't ready until essentially 1984. Any drives in computers made before that point were essentially on their own, and that includes the DOT, because as we saw, it was essentially finished in 1982. These Sony OAD30V drives were a bold move by Computer Devices to use. They weren't the first, that goes to the Jonas Courier, but they definitely weren't standard yet. But even worse, they weren't IBM compatible. In the lead up to the launch of the DOT, it was revealed that dealers would be able to purchase an $8,000 disk conversion kit to assist customers with converting the 5.25-inch IBM software to the DOT's 3.5-inch disks. Even ignoring anything with deep copy protection like Microsoft Adventure, this was not a foolproof solution. One DOT dealer pointed out later why. The DOT's floppy disks were only capable of holding 287 kilobytes of data, only 80% of what a standard IBM 5.25-inch disk can hold. Any software that used the whole disk would be impossible to convert cleanly. This disk format was also completely unique to the DOT. The OAD30V's 70 tracks are less than the proposed standard's 80 tracks, and they're only single-sided. All later IBM compatible computers with 3.5-inch drives were physically incompatible with the drives in the DOT. From all of my research, I could only find one software vendor who actually sold a program natively for the DOT. This meant that the DOT was instantly an outcast in the IBM PC compatible market. But the DOT finally made it to market in April of 1983. Sales were, as you would now expect, dismal. The DOT needed to be a hit for Computer Devices to make its money back on the development of its new machines, but it never reached any real success. The company attempted to get some quick cash in an attempt to change course and develop a DOT 2 with 5.25-inch drives. In July, they sold 1 million shares of stock at $11.25 each, but before the end of the month, the price would fall to $5.87 as confidence in the company shrank. Then, 6 months after the first DOTs shipped, Computer Devices Inc. filed for bankruptcy. Industry analysts had been speculating about the sales from the company. They were estimated to have sold between 2,000 and 3,000 DOT computers in that time. But during the bankruptcy, they sold the rights to the DOT technology to Prime Computer Inc. and disclosed that they had only sold 500 units total. Now, this book, Why Companies Fail, published in 1985, would go on to say that Computer Devices had been receiving orders of only 50 DOTs a month from dealers in the 4 months leading up to the bankruptcy. The example I have here is serial number 383. The newest date code on a part I found was 8321, which would be the last week of May. My computer likely would have been sold in June or July at the earliest. So the 50 units a month and 500 total figures sound devastatingly plausible. Computer Devices would later be sued by the shareholders who bought the 1 million shares for not disclosing these poor sales performance of their products. Somehow, though, CDI would make it through the Chapter 11 process and restructured. They lasted until 1998, but were a shell of their former glory. In a 1996 SEC filing, it was revealed that they had only 7 employees. They were also somehow still selling Series 2000 terminals, possibly large amounts of sold stock that were highly undesirable. There were a lot of small companies that came and went in the early days of computing. The industry was so much more diverse and interesting, but this is an example of one of the turning points of homogenization, and the market would not accept the DOT and its forward-thinking drives. But we can still admire the DOT for what it is, because it is quite frankly a fantastic machine. I want to start out here by showing you something that has never been recorded. This is the computer device's DOT booting up. There it is. This wonderful machine is sitting here running Microsoft DOS version 1.25. Now, at this point, I have a bold claim to make. This is the only functional DOT known to exist on the planet, mostly because of this floppy disk. This disk has an operating system on it that this machine boots. Now, I know of 2 other DOTs out there, but neither of them came with an operating system disk. Unfortunately, this is not a complete original disk. This one is someone's work disk that has many files on it that are not related to the machine. However, something that I can almost only describe as a miracle has happened. I bought this computer in April of this year. Yesterday, I had a package delivered. This is a brand new, complete in-box, unused DOT. We're going to be able to preserve every single thing that was available with this computer when you got it. So we are going to have an example of a complete correct set of operating system disks. But also, we are going to get to experience an unboxing of a computer device's DOT for probably the first time in 40 years. All right, let's get this open. You'll have to forgive me. I did undo the tape on this, but there's 3 or 4 layers of tape on here, so it's not like you were getting the completely original experience anyway. I would say several different owners of this have wanted to make sure it wasn't just full of bricks. Oh my gosh. The DOT software kit. It's sealed. It's perfect. We are so scanning all of the manuals and imaging all of the floppy disks in this. This is an absolutely insane find. Oh my gosh, I'm so excited. In the box, we also get a power cable and a roll of thermal paper for the printer. This is just regular fax paper. You can still get this today, so there's nothing too special about that. Now, though, oh my gosh, look at it. Before we pull this out, I do have one thing I need to take a detour on. Now you can see this handle. That isn't on the other DOT because it's actually on this case. This goes over the DOT and wraps around it and clamps on to make it more ruggedized and portable. That DOT came with this tag, and this tag has their Burlington office address on it, but it's some kind of field service material tag. It's dated July 27th, 1983, listed as tested. I don't actually know what this is. It's kind of weird. For all I know, this could have been a field service unit, but I'm not sure. It's also possible this was just one that got worked on in the field. Either way, you can see this one's pretty rough. This one, though, is absolutely flawless. Let's get it out. It's not a light computer, by the way. Ah. Oh my gosh, it's so perfect. All right, let's get this second one set up here. I'll undo the case while you guys can see it because it's really weird and I don't exactly know what they were thinking. There's this lip here that has to fold down, and as far as I can tell, you must hang it off at the edge of a table to do that. Then you undo these latches on the sides. And after that, it lifts straight up. So this one has an amber screen filter option. These are the same CRT, but this one has an amber filter over it. They did not come in different phosphors. Now, there's another thing that's obvious to me. This is a later Sony floppy drive, I think. This might be an OAD31V, the same as it's in the Jonos. Tells here, but for one, it looks like I can just put a disc in there right now. I should, in theory, be able to put my manual shutter disc in here. Yes, that is a later drive. So I'm pretty sure that's an OAD31V, which makes this a later model, which coincides with the serial number. This one is serial number 487. It was printed on the box, so it was really easy for me to tell. I'm very, very curious to see what the date codes are inside of this. Oh my gosh, there's 2 dots. Now, if you're wondering where the keyboard is, it's actually in the top of the case. And if I pull this out carefully, well, first off, there is the correct storage orientation for the keyboard. So the cable wraps around that side, around this side, and then the plug gets jammed in place there. I may never put it back like that because the cable and the plastic are not going to do kind things to each other. This cable does not appear to have been stored correctly, which has made it not be strained like this over the last 40 years. Now, you do, to get this out, have to pull this piece of plastic back, which is a little nervous on 40-year-old plastic. Oh, it worked out okay. And there we go. There is a label in here that tells you how to store everything. This is upside down. I'll get a photograph of that later and put it on my website if you want to be able to check that out. But that's a brand new keyboard. All right, the next thing we need to do, we absolutely must open this and archive the discs. There's no way I'm putting these floppies into any of these computers before they get imaged. All right, let's do this. Let's unseal the DOT software kit and get this preserved. It is genuinely blowing my mind to be touching this. Just wow. There it is. Oh, look at all. Oh my gosh, there's so much. So from what I've read, this should come with DOS, but it should also come with Volkswriter, the word processor program. It may not, though. Let's look at what discs we have. One here. The labels are starting to fall off. One here. And one here. Okay, so MS-DOS operating system. These are Sony pinch auto shutter discs. Okay. Man, can you tell I'm actually really excited about this? Dude. So we have DOS disc. Look at these little dot sleeves. Oh my gosh. Okay, here, DOT. Is this a blank disc? Did they gave you blank floppies? That was smart. I mean, it wasn't smart enough. Wait a minute though. Is that it? We get DOS? That's it? Oh man. That is rough. Well, it looks like there is probably only one floppy that we need to image here. So let me go get that done. Oh my gosh. Okay. This disc is now imaged. So we can do almost anything we want. Now, unfortunately, I want to open this and look at it because I want to make sure there's not like exploded caps or anything in there. And there's a couple of things I need to do. But I do want, before we do that, to open the Meet Your DOT guide, because just I have seen literally zero documentation about this thing, and suddenly we have a treasure trove. So here we go. Guide to documentation, Meet Your DOT. I love that they show a full-on Sony disc right there. Yeah, you know, actually, this is a good point to mention something about the computer that literally no review ever covered of this machine, and I don't understand why. The computer has a BIOS menu on it. And one of the things that you can do from the BIOS menu is just go into a terminal mode. So right here, use as terminal. I've never tried this. Hit any key to return to the monitor, any function key to return to the monitor. There we go. Okay, so, all right, so that's how that works. So from terminal mode, if I do say Control G, oh, I guess we don't have full duplex. So I don't know how to use the terminal mode. This is one of the reasons why I actually never launched that, because like, what baud rate is it? How do I change the, parity? Is it local loopback? So there's like no information about it. Oh, here we go. Changing the setup mode parameters. Dot stores as memory. Enter the setup mode by holding the Alt key and pressing the Escape key. Alt key. Oh, okay. Baud. This is 110 baud. Ouch. It looks like it was set to 80 by 16 as well. Do we just hit enter? This key is not used. Hit F10 for help. F10. Actually, this is pretty good. Other than not having Alt Escape documented anywhere, the online help seems pretty good. 132 by 25. Okay, let's pop the disc in. I want to see that. Terminal mode. Wow, that's tiny. Oh my gosh. That's so small. Whoa. Manual was just helpful. I would have never guessed Alt Escape. All right, the next thing I need to do is take this unit apart for two main reasons. One, I know there's a card in this one that needs the capacitors replaced. So there's a good chance that the same card could exist in this one that also needs to be replaced. And two, I need to look at the printer belts. You'll see why in a moment, but it's pretty important. Never been turned on. We're gonna just tear straight into it. This is ridiculous. The way this works, it's really, really awkward to take this thing off. Like I've obviously done it on the other one. I took a bunch of pictures too of that inside. You take out these screws and then the top shell kind of slides back, kind of slides up. It's a little weird. I didn't feel really confident about it the first time I did it. So hopefully this one goes a little smoother. Kind of pull it back. Oh, that one went way, way smoother than the other one. Look at this cute little card brace. Oh my gosh, I have never seen anything like that. The other one definitely does not have that. That is adorable. All right, now the latest chip on that one was this one here, and it is the same 8321. Now, the ROMs. I've actually dumped the ROMs on that one already, so I don't think I will need to dump the ROMs on this one, but I can do that later. For right now, we do have a set of the ROMs dumped, so I'm not going to rush that as a priority. That board, the motherboard on that one was etched Rev C. This one is etched Rev D1. They were selling this thing for 6 months. They have so many revisions that were actually sold. It occurred to me while I was editing later that I didn't actually talk about what this card is. This is the IBM compatible component to this computer. That's the 8088. This is the BIOS here. There is the RAM. So this could be considered the motherboard for the computer, but this is also the motherboard. It just has the floppy controller, printer interface, serial ports, and all of the interface options on it. One of the reasons why it's like this is because there was also a Z80 card available for the DOT. I haven't actually seen any proof that they were shipped, but they might exist. I don't know. So this is only what would be needed to run as an IBM PC compatible. If you had the Z80 card, which might replace this actually, I don't know, then you would have a Z80 and probably a completely different board in here to go alongside it that would allow it to run CPM. But this is what makes this computer IBM compatible-ish. All right, this card, CRT. Okay, so that's the video card. So I would explain why it has its own memory over here, because I think it had like 7K of video memory or something. But these little caps here, those are the ones that need replaced. All right, now let me get you some tight shots of the inside of this so you can understand exactly what was happening at CDI during this time, because I fully believe they only made 500 of these based on what it looks like inside. Right here on the back is the keyboard connector. You can see it right there. Every pin going to that connector is hand soldered to the PCB. Everywhere on every board are wires like this that were clearly bodges for something. They're all over the place. All of those would have been hand done as well, and probably that is the Rev D difference there. I wonder what's wrong with the other one that was fixed on this one. Now this one's a little difficult to see, but this board down there you can see is labeled head load logic because the Sony drives were more similar to the 8-inch drives than 5 1/4. They require a separate signal to load the heads. So this probably has a standard PC floppy controller that does not send a head load signal, and this is a daughter board that is actually plugged into a 40-pin socket on the motherboard that adds it. So I'm going to guess that's the regular floppy controller for a PC, and then it has additional logic on this board for head load, and that they didn't realize they needed that until after they made the motherboard. Now, I've mentioned I'm really excited to see these belts. We can start to see it here. They're like molding or something. I'm not exactly sure what is happening here, but the other dot is much worse to the point where it is impossible to read anything off of the belt. Now, I've been trying to figure out what size belts these are for the other one since I got it a couple of months ago now, but I haven't been able to find any information because, I mean, well, it's a dot. There's nothing out there. I was able to buy this. This is the printer manual for the module that is the Q3 thermal printer that was put into the 1200 series terminals. So I do have, let me find the photo of it here. I do have this, but this one is different. This is Q150. This is probably the same as what is in the Series 2000 terminals, but it's not a Q3. So this manual was of no help at all. But I'm really hoping I can read the tooth count and pitch off of these belts. So I'm going to spend some time trying to find that on here. We'll see if I have any luck. All right, I've had a good look over the whole thing. There's no markings on these belts. There is no way to just tell what they are. It's really unfortunate. On my HP thermal printer, they were marked and you could order those. I think the belt in the HP 85 might have been like that as well, but not these. So because these are still intact, I'm going to remove the belts from this printer and then just count and measure the tooth spacing so that I can order belts for both printers for the Q150 model because, yeah, I really like the printers to fully work. There we go. That's intact. We can count and measure that one for sure. The other one looks a little worse. It may not survive this. Now this one, I'm unsure of the best way to handle. There we go. Okay. Didn't shoot it across the room or anything. Oh, what's this white bar? Oh, it's so in the way. Do I pull this off and then try and... Oh boy, don't lose this. Knew that was gonna happen. Oh my gosh, there's so many places it could have gone. We got both belts off with all teeth intact. And only lost one E-clip. Oh gosh, I have to find that now. Looks like I might be removing the printer anyway. Okay. After fully removing the entire thing, there it is. While I had it open, I've also taken some nice photos of some of the stuff so I could document some of the inside here that I couldn't previously, so that's a little nice. Little fun fact here, the CRT set appears to have been made by Sanyo, but the tube itself is made by Toshiba. So we're just gonna skip right to this thing being back together. Okay, this is hopefully back together now. Anyway, on to the next thing I need to do, which is recapping this card. I was looking over this one from this computer. The caps on this one look okay. It might be fine. I'm going to go ahead and open the other one and pull out this card in there, and you'll agree, yeah, those caps need to be replaced. So I think we can put this one back in there without worrying about it. Oh, that worked out better this time. Okay, I need to go back and review my footage of disassembling that one. because I'm seeing that this connector is plugged in backwards compared to this one, and now I need to double check how it was plugged in initially. All right, so you can see the same card here with the CPU right there. That's good to know. But then we get to this card, the one that I'm saying needs to be recapped. You can see the fuzzing happening on the leg of the cap there. So that thing is bad and definitely needs to be replaced. For comparison, the other card, we can't really see the legs as well, but what I can see under there looks totally fine. And here is why I was excited to see the other belts. These ones are in way, way worse condition. I just went back and checked the footage. That connector was the correct orientation. This one is wrong. I don't understand that. All right, I'm gonna try something weird. I'm gonna power this with that connector disconnected, and I just wanna see what the printer does. Okay, card's installed, cable disconnected. CRT is on. Keyboard error. Yeah, that's to be expected. Okay, and then I plug it in. I'm starting to think it's going to test the keyboard first. Oh, nope, there it is. That's correct. Is that one even going to work? Okay, I have to know. I have to know. We're powering it. I gotta know. So we'll be looking for this to move, and maybe that, if you can see that, I don't know. But I have no idea if this is going to work. I feel like it's not, and that connector was wrong from the factory. That immediately. Okay, that's the first time this has ever been plugged into power. Here we go, hitting the switch. Please don't explode. CRT, okay. All right. That's looking correct. Dude, I hate that filter. I want to power cycle it one more time because I want to like try and figure out what that weird sound is. What on earth is that? It's nothing here. Is it this or is it a fan? I think it's a fan in there. Yeah, that is weird. Okay, if I wasn't so busy being weirded out by the printer, I would be ecstatic. The second dot works, okay? That's awesome. But this printer thing is really weird. All right, every single one of my images from when I first opened it shows it like that. All right, let's try it. It did stuff with the printer. Keyboard error. I'm gonna have to plug in the keyboard. I gotta know. All right. All right. Run extended diagnostics. Model system RAM. Oh, it's 128K. Okay. I don't know. You know what? We'll leave it be. All right. Let's see if it'll boot. Now, this is not the new disc. This is the one from that computer. And it works. That means the drive is good. Dude, these drives are so picky, man. That's a huge hurdle to clear. Okay, 128K RAM on this one as well. Okay. Before I try and put the other MS-DOS disk in, I'm going to recap this card so I can stop being concerned about running the super ancient, decrepit, corroded caps on here. Just be clear to continue. All right, this is recapped. So let's pop this back in there, and then I think these are just ready to go, other than the printer that I can't do anything about today because I need to order belts. Let's turn this one back on. Didn't explode. I like it. Boom. That is the CRT card, so that's basically all the test I need. Well, with that, I think it's time to button the computers back up and just use them. All right, here we go. I'm going to turn on the first dot. It already has its original disk in there still, so it will boot up using that. There we go. But then this. the second DOTS operating system disk. Let's boot this for the first time ever. Oh my gosh. That's so awesome. Enter new date. I think we can skip all that. There it is. Durr. Oh, that's fantastic. That's everything we could want. Oh, that's so awesome. Well, there they are, fully working, running their operating systems. It's a totally normal operating system, but I have the same problem that everyone in 1983 had. I don't really have a way of getting data onto these. The problem is, these are not standard format disks. So I can't just say, put this disk in a newer computer and write data to it, because it can't read or write to it. Now, for some reason, the images that I can decode from these aren't just FAT12 file systems. So I can't mount them in 86 box or something, add data to them, and then continue on. They just don't make sense for anything else. So if I'm going to attempt to get data onto these, I'm gonna have to do it over the serial ports as if it was like an Apple II running ProDOS or something. Now, there might be a way to do that, but that is gonna be a little bit more complicated than I think I want to get into for this video. So I don't want to spend too much more time on that, but it's just suffice to say, their main problem back in the day is still a problem now. But there are some things that we can check out with this. While we have both here, let's try the terminal feature with the two connected to each other, and then we'll check out DOS and what we can do with that on this one, because it's a lot easier to see without the filter installed. Okay, so I've got a serial cable here with a null modem adapter on it. So I'm gonna pop the operating system disk out of this one because we need to run the BIOS programs. All right, use as terminal. Here we go. Boom! That's so cool. Oh my gosh. Yeah, I can't believe that it was never mentioned that these work as terminals. It's like their whole thing for computer devices. It's such an important part of this thing's identity. Man, just crazy. Okay, I'm wondering what the print screen button will do here. Nothing? We have a paper line feed dedicated button? I did not realize that. That's kind of hilarious. It doesn't work here. Oh, come on. There's gotta be a way to print the whole screen. Dude, I don't know, man. There's no information about these. I do have some good news. I have the service manual coming for these. So I might be able to figure this out later. All right, well, let's call that for now, and let's focus on using DOS on this one. There's clearly something weird going on with the printer stuff. I still think it's the connector, but yeah, let's just not mess with that for right now. Now, I'm pretty sure the first thing we have to do here is try booting DOS in the super high resolution video mode, because it will be ridiculous. Let's boot our MS-DOS disk here. Oh, it changed the setup. Interesting. Okay, well, let's figure out what the mode command is for that, because I know the manual mentioned it. Oh, what just happened there? Okay, so it was the errata readme first thing that describes mode. So it'd be mode V colon 132x1 or 25. But I'm not sure the CRT is going to turn on again here. So let me try this out. We might be waiting for a part 2 here. Okay, it did pop up. Concerning. Config power fail. Config RAM error. Power fail. Okay. That's a different one. I'm gonna, Well, that's not good. So if I was to guess, we may not have the negative voltage rail for the RAM if it needs it. That might be what's happening. I am not equipped to try and repair the power supply right now, so that will have to be a later project. All right, the computer's had like a half an hour or so to think about what it's done. Let's see if it turns on now. Okay. Definitely going to be power supply. All right, that's good. Let's use the other one for now. We'll let this one be. All right, let's give this another shot with the new dot. I'm gonna keep this brief for the rest of the video, I think, because we clearly have a part 2 coming up. But I at least want to try changing the text mode here in the DOS. And then I want to try running a text editor. I think BASIC can do that on here. Not sure about in DOS 1.2.5, but we'll see. So to switch to 125, we're going to run mode and then v:132. That's 132 by 25. I mean by 25, and then that's amazing. Okay. Wow, that's crazy. Here using .basic. Okay, we just run mbasic here. All right, so mbasic. If I were to write out a longer program, rem, this is a comment, 20, print some data. It may not like that without quotes. I don't know. 30, rem. How long of a line can I type in BASIC? Because this computer is awesome and oh, we're limited to 80 lines in BASIC. No fair. Oh. Here's a much tighter shot on this. That's very interesting. It's running at 60 hertz, by the way. Yeah, this is super duper cool. So I can run, it'll print syntax error in 20. Okay, we might need quotes. Print. Oh, it's angry. Okay. Quit, or is it going to be exit? System. That's a weird thing. Here we go. Dir. So we have command com, format, debug, edlin, check disk, sys, file com. I don't know what that is. Exe to bin, mode, mbasic, and disk copy. That is everything that we have there. No config sys, no auto exec by the looks of it. So yeah, that's a pretty bare bones thing there. Format might be unique to this machine. Well, I guess there's nothing I could really do more in DOS in 132 by 25 mode. This tells me we would actually need the copy of Volkswriter made for the DOT to do this resolution mode. I don't know if a generic copy of it would support this or not. I have a feeling it wouldn't, so that's a bit of a shame, but hey, it works. I mean, better than the other one, at least. The other one does work too, just you're gonna need a little help. Well, there it is, the computer devices DOT. I am so excited that I have, I mean, 2 of them. I would have never guessed that. And this one being brand new is just mind-blowing. I have to give an enormous shout out to Digital Ice Age for helping me research this thing. I could not have done it without you. Thank you so much. But that is going to be all for now. I have a lot of archiving and preservation ahead of me with this machine because I got a ton of material with the complete in-box one that needs to be preserved. And I have the service manual for this machine on the way. Hopefully that'll tell me how the printer connector is supposed to go. I also clearly need to recap the power supplies in both of these. I need to find the belts for the printers so we can try that. So clearly there will be a part 2, but I think this was a great introduction to this completely forgotten machine. It is incredible. I will be releasing images of the floppy disks. If anyone wants to help me try and get files onto this, I would be extremely appreciative of that. My next attempts are going to be using Kermit to transfer data over, but with the shakiness of the power supplies, I'm going to prioritize working on that. So unfortunately, I wasn't able to get to that today. So we'll see if we can figure out how to get files onto here. But for now, that is it. I hope you guys enjoyed this look at this wonderful machine. I'm so happy I was able to share it with you. If you want to help support the channel, you can find me on Patreon. But for now, that's it, and I will see you next time.